Hi everyone, so this video is on reciprocal trig ratios. Reciprocal means flipping a fraction, and you'll see where that comes from here in a second. So I wanted to remind you, first of all, I'll go back a little bit. When you have a right triangle, that's all trig is about. And trig, we've talked about these three ratios. Sine, which is just a ratio of the opposite side to the hypotenuse. So say we're looking at angle A here, that's the opposite side, that's the hypotenuse, and that ratio, we just label that sine. Adjacent over hypotenuse, we label that cosine. Opposite over adjacent, we label that tangent. But there are some other combinations here. For example, sorry my board's tripping out. Let's say instead of opposite over hypotenuse, what if I wanted to say hypotenuse over opposite? Why not? This has a name. It is called the cosecant. And we'll write this down more in a second. But it's called the cosecant, abbreviated CSC. And so basically it's just the flipped version of sine. Let's say instead of adjacent over hypotenuse, we wanted hypotenuse over adjacent, the flipped version of cosine. This one is called secant. Oh, we just lost all color. Not sure what's happening. Secant, abbreviated SEC for secant, and it's just the flipped version of cosine. And then we have one called cotangent that goes with tangent. And so the cotangent is the flipped version of this. It is adjacent over the opposite. So let's write this out, and I just want to spell them out for you. So we call these reciprocal trig ratios because you literally take sine, cosine, and tangent and you flip the fraction. That's what a reciprocal is. These are different from the inverses. These are not inverses. They don't undo each other. Like cosecant does not undo sine. It's just the flipped version of sine. The inverses are something else entirely. Okay, so cosecant, abbreviated CSC, goes with sine, and then secant goes with cosine. I know that's a little weird that cosecant goes with sine and the secant goes with cosine. It seems like the two cos should go together, but they actually don't, so be careful of that. Cosecant goes with sine, and then secant goes with cosine, and then this one makes more sense. Cotangent and tangent go together. Okay, so again, the cosecant is, instead of, like here's so, ka, toa, so cosecant, instead of being opposite over hypotenuse, is actually hypotenuse over opposite. That's also the same thing as doing 1 divided by the sine. Because if you ever do 1 divided by something, it flips the fraction. For example, if I do 1 divided by 2/3, I'm going to get 3/2. Because watch, you keep the first number, you change the division to multiplication, and then you flip it, so 3/2. And so 1 times 3/2 is just 3/2. So basically, doing 1 divided by something flips the fraction. It's the inverse, or the opposite, the reciprocal, sorry, not inverse. Secant, once again, rather than being adjacent over hypotenuse, is hypotenuse over adjacent. And cotangent, rather than being opposite over adjacent, is adjacent over opposite. Once again, these three words are just names that we assign to specific ratios in a right triangle. Let's go through a couple examples. First, I just want to find the sine of angle C. So if it helps you to write out SOHCAHTOA, this tells me that the sine is opposite over hypotenuse. And we're looking at angle C, which is here. So compared to this angle, that's the opposite side, and this is the hypotenuse. So opposite over hypotenuse would be 15 over 17. Again, sorry the board's tripping out. All right, cosecant of angle C. is literally sine but flipped. So rather than being opposite over hypotenuse, it's hypotenuse over opposite. It's literally just this but flipped, 17 over 15. Or if you want to do it the long way, it would be 1 divided by this, 17, which would be keep the 1, change the multiplication, flip, which would give you this. So either way. Cotangent is, it's the one that goes with tangent. So rather than being opposite over adjacent, it's adjacent over opposite. So let's go find angle C. There's the adjacent side, 8. And the opposite is 15. And then the secant, remember secant goes with cosine. So rather than being adjacent over hypotenuse, we'll flip it and do hypotenuse over adjacent. So this one's angle A. So this time we're looking at angle A here. So hypotenuse, 17, goes on top, and the adjacent side to angle A is 15, because it touches angle A rather than being across the triangle. So there we go. And you are going to need to memorize which goes with which. So like you're going to need to know cosecant goes with sine, secant goes with cosine, cotangent, and tangent. Just a couple more examples. This one says, and you may want to pause the video and try these yourself. These are good little challenge problems here, and then watch the video as I go over it. It says the sine of x is a half. What is the cosecant of x? It's literally just this but flipped, because cosecant is the reciprocal of sine. So it would be 2 over 1 rather than 1 over 2, which is just 2. And then this one says if the cotangent of x is this, what is x? So basically I need to undo cotangent. And there's not a button for that on your calculator. There's only a button for undoing sine, undoing cosine, and undoing tangent. So here's what you can do. Rewrite this with tangent. If this is the cotangent, then the tangent is the flipped version of this. Rather than square root of 3 over 1, it would be 1 over the square root of 3. These two things are identical. If the cotangent is this, flip it and you get the tangent. Now I can use arctangent or inverse tangent to get rid of tangent and get just x by itself. So do inverse tangent on both sides. Make sure you're in degree mode on whatever calculator or website you're using. So I'm going to type arctan or inverse tangent. Oh, let's make sure I'm in degree mode. Yeah. Of 1 divided by square root of 3, which I got 30 degrees. Okay. And our last little challenge here, again, if you want to pause it and try it yourself, you can, because the practice is going to be really fast. If sine is a half, what is secant? This one's a little tricky because sine doesn't go with secant. Sine goes with cosecant. The one that goes with secant is cosine. So what I'm going to do is actually try to figure out the cosine first, and then I can flip it to get the secant. If you're ever in doubt, try drawing out a right triangle. I don't know exactly what it looks like, but we're going to go with this. We can call that x. It says sine of x is a half. Sine is opposite over hypotenuse. So the opposite is a 1. The opposite side is a 1. The hypotenuse is a 2, or at least that ratio. If I want to find the cosine of x, that is the adjacent over hypotenuse. I have the hypotenuse, it's 2, but I don't have the adjacent side yet. to find that, I'll actually need to do Pythagorean theorem. So let's just call this A for adjacent. So 1 squared plus the adjacent side squared equals the hypotenuse squared. 1 squared is 1. 2 squared is 4. Subtract 1 from both sides. So A squared equals 3. Then square root. So A is the square root of 3. So all that was just Pythagorean theorem to find this missing side here. And so now I know the cosine is square root of 3 over 2, adjacent over hypotenuse. Then to find the secant is just the flipped version of that. The secant is, instead of adjacent over hypotenuse, it's hypotenuse over adjacent. So it's 2 over the square root of 3 rather than this. It's just a flipped version. Technically you should simplify that because you're not supposed to have radicals in the denominator, so you should multiply by square root of 3 and square root of 3, which could give you 2 root of 3. Square root of 3 times square root of 3 is just plain 3, and that would be the final answer. All right, there's some practice that should go very quickly. I don't make you do any crazy challenges like this. It's just some basic like trig stuff, just 3 problems. It's also on Google Classroom. Just so you know, this is technically not even in the geometry standards, but I figured I'd go ahead and throw it in there just to give you a little preview of what's to come while we're talking about this trig stuff. Okay.